Dear friends, I myself, Dr. Bharat Parab, discussing today linear equations in one variable. There are two terms, expression and equation. Expression means some such thing 2x plus 3. It doesn't contain equal to sign. There is absence of equal to sign. But equation means such thing it contains equal to sign. Some simple problems. Now let us solve some examples, some problems where one variable is involved. Let us take very simple problem as very simple x minus 2 equal to 5. So this minus 2 is to be taken the other side of the equal to sign with change sign, or sign will change. So this will become x equal to 5 plus 2. So that is equal to 7. Okay, very simple. Now another example, which is y upon phi equal to 9. X, y, z, all these are unknowns. Okay. Now as in the denominator form, it will go to the numerator in the next side of the equal to sign. So you get y equal to 5 into 9, and the answer will be 45. Okay. And the third example will be, these are very some simple examples involving one variable in a linear form. Linear means, as I told you in the beginning, linear means having only one power, not more than 1. X upon 2 plus 1 is 8 upon 5. So go there with change sign. So x upon 2 equal to 8 upon 15. So actually students should try this on their own. Try many examples as is possible, that will make you master in this. So x upon 2 is with LCM. Every example is actually a challenge, but the moment you try to solve it, it's no more example, no more a problem, it just becomes an example. Okay, you can see this is transferred there in the numerator side as the denominator in the beginning, and the answer you get is x equal to minus 7 upon 15. 2 is minus 14 upon 15. Okay, now we can check it by putting this value in the original problem. Okay, no problem. A base of an isosceles triangle is 4 by 3 centimeters. The perimeter of the triangle is 4 and 2 by 15 centimeters. What is the length of either of the remaining equal sides? Now, to solve this problem, okay, consider an isosceles triangle where two sides are equal. This and this is equal, and this is base. The other is a base. So these sides are equal. Let us consider these sides as x, and so the perimeter will be addition of these two, all three sides, these two sides and a base. So that is a perimeter. And so we take it as okay, perimeter equal to x plus 4 upon 3 centimeters. Remember, units are very important. Okay, so 2x plus 4 upon 3 is equal to 4 2 by 15, that is 62 upon 15. that is very simple, that 15 into 4 plus 2 is 62 upon 15. So we go ahead, this will be shifted to the right hand side, and with a change sign, then 2x equal to 62 upon 15 minus 4 upon 3. Then we take LCM here and get 15, that is 6, which is 62 minus 20, and you get this answer 2x equal to this. So x equal to, this will go to the denominator side, and you get final answer, x is equal to into 112, that is 21 upon 15. Divided by 3, you get 7 upon 5. So that is your final answer, 7 upon 5. Very simple. Okay, if you practice it, there is, these examples are very simple, there is no problem at all. Okay, do not forget units. Okay, that is very important, centimeter, meters, etc. Okay, the three consecutive integers are such that when they are taken in increasing order and multiplied by 2, 3 and 4 respectively, they add up to 74. Find the numbers. So whenever you come across such type of examples where uh, you have to define some consecutive numbers or numbers with some difference or multiples of some other number, then it is advisable to take numbers in the following manner. As now, as these are consecutive numbers, we take it like this. Okay, as the middle number will be x, and a number before that will be, previous number will be x minus 1, and another number will be x plus 1. This is for consecutive numbers. Okay, that makes your problem simple. Okay, this doesn't matter much if you take x plus 1, x plus 2, you also get the answer, but this will make your calculations very easy, as you can try. So we go ahead, this is given in the example, that so we multiply first number by 2, second number by 3, and the third number by 4, and it gives addition 74. That is given in the example. Okay, so we solve it. Open the bracket, 2x minus 2, as you can see, this is very simple. And now collect x. So 2 plus 3 plus 9 is 4 is 9x, and minus 2 plus 3 is plus 2. As you can see here, collect all x and all constants, the numbers, only numbers which doesn't contain any unknown, multiplied to it, that is in this case is a minus 2 and plus 4. So you get 9x equal to 74 minus 2, so that is 72. The x equal to 72.9 is x, very simple. You multiply by 9, divide by 9, and you get 8. Hence the number will be, see, we have taken x, the middle one, so 8 will be in the middle one, so another number will be 8 minus 1. Remember this. Okay, so 7, 8, 9 will be the numbers. The ages of Rahul and Harun are in the ratio 5:7. 4 years later, the sum of their ages will be 56 years. What are their present ages? So we are solving another example where you are dealing with a ratio. Whenever you come across such problem where ratio is involved, okay, do follow this method. In this case, Rahul's age and Harun's age is the ratio of 5/7. So take Rahul's age as 5x and that of Harun's as 7x. Okay. So if you follow this, whenever you come across a ratio, that will definitely make your problem very easy. So that now see, Rahul's age and Harun's age ratio will be, we are trying to find out this, that will be of course 5x upon 7x is 5 upon 7 as given in the example. Okay, 5 upon 7. Now as given it, after 4 years Rahul's age will be 5x plus 4. Okay, that is very easy to understand, very simple statement. And Harun's age will be of course 7x plus 4. And then as given in the example, you have to add and go ahead. I am going very slow because though examples are easy, you need to understand it, you need to practice it yourself, understand it very properly. Now it is 5x plus 4 plus 7x plus 4, addition of after 4 years is 56. Now add all x and the constant without x, like 12x plus 8 equal to 56. 8 goes on the right hand side and equal to 12x as given in the other example also, that becomes 48. So the x will be 48 upon 12. So you divide by 12, that is 4, you get x equal to 4. Now see, this is the value of x. Rahul's age is 5x. Okay, so do remember this. So Rahul's age will be 5 into 4, it will be 20 years, and Arun's age will be 7 into 4, that will be 28 years. And don't forget the units. In this case it is years, maybe centimeters, kilometers, kilo, etc. Okay, you should always remember this. Mohan's father is 26 years younger than Mohan's grandfather and 29 years older than Mohan. The sum of the ages of all three, Mohan, Mohan's father and Mohan's grandfather, is 135 years. What is the ages of each one of them? So we are dealing with a example where uh, ages of three people are involved: Mohan, Mohan's father, and his grandfather. Okay, so the Mohan's father age will be in between these two. So take that as x. So that makes your problem very easy. So father's age will be x, then grandfather's age will be x plus 26 years, and Mohan's age will be x minus 29, as 29 years younger than his father. So these are the three quantities we need, and we go ahead and as given in the example, we add these. X plus 26 will be grandfather's age plus x Mohan's father's age, and x minus 29 Mohan's age, and the addition will be 135. Okay, so we add all x and all constants. So 3x minus 3 equal to 135, very simple. So 3 goes on this side and it will be x equal to 138 upon 3. We multiply all this, divided by 3, and get 46. So x was taken as Mohan's father's age, remember this. So that is 46. So grandfather's age will be 46 plus 26. Okay, that will be 72 years. And Mohan's age, Mohan was 29 years younger than his father. So it will be x minus 29 is 46 minus 29, it will be 17 years. Okay, so this is how I have to solve such type of examples. Okay. We write it in a series. 17 years, father is 46 years, and grandfather 72 years. Lakshmi is a cashier in a bank. She has currency notes of denomination rupees 100, rupees 50, and rupees 10. The ratio of the number of these notes is 2 is to 3 is to 5 respectively. The total cash with Lakshmi is 4 lakh 400,000. How many notes of each denomination does she have? So let us try this example. As I told you in the beginning, whenever you come across such problem where a ratio is involved, then follow this method as we have followed it in the previous example also, and that multiply this ratio by an unknown x, that will be your variable. Okay, so let us go ahead. Now as given in the problem, let rupees 100 notes be 2x, as the ratio is 2 is to 3 is to 5. So 100 notes will be 2x, then 50 rupees notes will be 3x, and 10 rupees notes will be 5x. So that will be in the ratio 2 into 3 into 5. Now the value of 100 rupees notes will be 2x into 100. Very simple. Okay, then 50 rupees will be 15 to 3x, and 10 rupees as given, so it is given here. Okay, and the total value is 4 and 50, that is 4 lakh. So solve this. 200x plus 150x plus 50x equal to 400,000. So that will be 400x equal to 4 lakh. Okay, so x equal to 400 will move on to the right hand side in the denominator's place, and we cancel these zeros and we get x equal to 1000. Okay, so 100 rupee notes, there are 2x, that means 2000. 50 rupees notes will be 3000, and a 10 rupees note will be 5000. Okay, so that solves your problem very easily if you keep the ratio same. So write it. Don't forget to write the units. In this case it is rupees. So you can check by putting these values in the original example and check whether it is right or wrong. If consider two-digit number, their digits are interchanged and are asked to find the number by the relation given between these digits. So if you come across such type of examples, try to understand this, that solve such type of examples, take the two digits as xy. Okay, now remember, this is not x into y, this is xy, just two digits. I am giving an example here. Take example as 46, where x is 4 and y is 6. We write xy, that means we are writing 46. Okay, now the value of xy will be given as like this: x into 10 plus y. Okay, in the above example it will be 4 into 10 plus 6, that will be 46. Got it? Just understand, this is the only core part of the problem. Okay, if you understand this, problem is no more a problem. Okay, then try to replace y in terms of x. This is another term where you are supposed to solve the problem with only one variable. We are introducing two variables, that is another variable, but we have to convert one variable in first variable, that is x. So what is converting or denoting y in terms of x is something like this. There will be uh, some uh, condition given. The difference may be in difference in the two digit may be 2, or one digit may be in multiple of another. So if you take y minus x equal to 2, then y equal to x plus 2. This is expressing y in terms of x. That will solve your problem. Okay, I have explained this in the example ahead, or you can go and try it there. You can understand it. Okay, so this is y in terms of x. Put this y value in x. Don't get confused. uh, Try to understand this in the part ahead of this. Okay, so uh, how will you know that y is bigger? Y minus x equal to 2. If you want, you can try with x minus y equal to 2. You will get the answer. If you don't get any answer, you face some difficulty, write me in the comment box and I will try to solve your problem. Okay, this is Dr. Bharat Parab for you. Try it, practice the examples, and try to solve as many examples as you can. One of the two digit of a two digit number is three times the other digit. If you interchange the digits of this two digit number and add the resulting number to the original number, you get 88. What is the original number? So here we try to solve the actual problem. You heard what is the problem. Now the consider the two digits of a number as xy. Remember, this is not x into y. I'm again repeating it. We have seen in the previous section that this is not x into y, but this is xy, just two digits. Okay, now as given in the problem, one digit is three times the other. So let us take y is equal to 3x. Okay, this is your example A. Okay, equation A. Yeah. Then as I told you, the value of xy will be x as in the tens place. So multiply this x by 10 and add y to it. Okay, so this will be 10x plus y. This will be value of xy, and if you interchange the unit, that will be yx, but the value will be, as y is in the tens place, y into 10 plus x. Okay, if you understand this, then you are understanding what is required for the problem. Okay, now we are interchanging these units as yx, and the value will be, say, y into 10 plus x. Okay, so these are actual values. Okay. Now as given in the problem, that the main digit and interchange digit, if you add, that will sum up to 88. Okay, see, this is only about understanding the problem properly. Now we are adding this is one value, 10x plus y is one value, and y into 10 or 10y plus x is another value, and that sums up to be 88. Now we are replacing y with the given in the equation a, okay, as this is y equal to 3x as given in the example. See, this is here. Okay, so we go ahead, 10x plus y is 3x plus, now here y again is 3x plus x, so that brings your equation in one variable. You add it up, so if you add it will get 44x equal to 88, so x will be 88 upon 44, that will be 2. So one digit is 2, another digit is 6. Okay, try with interchange digit. Okay, you will get the answer. Now these are the units 26 or 62. Read such type of problems very carefully. In fact, you must read any problem very carefully, understand it, and then solve. Half of the herd of deer are grazing in the field, and three-fourths of the remaining, remember, remaining, are playing nearby. The rest 9 are drinking water from the pond. Find the number of deer in the herd. We are solving another example. Whenever you try to solve the maths problems, okay, read it carefully. Read these problems very, very carefully. Try to understand the meaning behind it, okay, and then try to solve the problem. Without understanding even simple hints in between, you will get confused. So don't do it. Okay. Now in this, read it very carefully that half of the deers are out of the available deers in the herd, half are grazing. Okay. Then of the remaining half, okay, here half of the total are grazing. Got it? Okay. If you think it, no problem. You will face absolutely no problem. Now, three-fourths of the remaining half, okay, three-fourths of the remaining half are playing, not the total, okay, remaining half. So, do note this point. That is very important. And of the remaining half, one-fourth makes the three-fourth goes away for playing, then what is remaining is one-fourth. Then one-fourth is that 9. What he says is rest 9 are drinking water from the pond. So rest means out of half, three-fourth are playing, and a rest, that is one-fourth part, is 9. Okay. Then he makes, that is for one part is, he makes 4 parts. Then if one part is 9, then the 4 parts will be 36. This 9 or one-fourth and this 27. See, we are trying to see how many of are playing. That is 3/4. If x is 36, then 3/4 of x is 27. So 27 are playing. The x we have taken as the half of this. So half are 36, then half are grazing. So that comes to 72. Okay. So this is how you tackle with the problem. Mm. So it is very easy if you think it. Got it? The 36 into 2. So we have the number total number. Then how many are playing? That is 27. And how many are drinking water? Is 9, which is given. Okay. So try to understand this. Again, I am saying this. Okay. And the hinge in this, there is some hinge in every problem. That makes the problem difficult. So try to understand it. If you have any problem, write me in the comment box and I will solve it. Okay. I am Dr. Bharat Parab. Students, problems. Problem 1a. 3 into 5z minus 7 minus 2 into bracket 9z minus 11 equals 4 into bracket 8z minus 13 minus 17, and 0.25 into bracket 4f minus 3 equals 0.05 into bracket 10f minus 9. Now we are trying to solve some problems. Okay, read this. That is what is given in bracket is 5x minus 7 multiplied by 3, then minus 2 in bracket 9x minus 11, and it is equated to or equal to 4 into 8x minus 13 and minus 17. Okay, now try to solve the bracket first. Okay. Multiply the bracket with 3 and another bracket by 2 as given there. So if you have enough practice, there is absolutely no problem in solving this. Okay, so try to get a practice. Even if you know, practice it. Practice makes your subject easy. Okay, do solve it yourself and then see the solutions. Try it. Okay, that will make you perfect. Okay, so I have solved this. Now after all this, bring all x on one side and constant on the other side. Okay, generally we take unknown like x on the left hand side and constant on right hand side, though there is no such hard and fast rule, but that is just a practice. So I will transfer this 21 and 22 there and like this. Okay, so we are going ahead so that it will be very easy to add or subtract whatever it may be. Got it? 15 makes this whole is. Now in this I have transferred, I could have done it left hand side plus 1. That can also be done. This is general practice. This is particular for this example, or generally we transfer the whole things on the right hand side or on the left hand side, then try to solve it so that you don't get confused. Okay, so you can see minus 3x minus 32x equal to minus 69 minus 1. So 35x is minus 35x equal to 2. So that goes along with the negative sign in the denominator, and you get x equal to 2. Okay, very simple because you have practiced it. Okay, this is one example, and another where point is involved. 0.25 is 1 by 4, 1 upon 4, but we have to we should have that practice also of solving with points. Okay, 0.25, 0.05, 0.5, like that. Okay. Now you see this, so 0.25 into 4, okay, f minus 0.25 into 7, 0.23 equals, okay, now 0.25 into 4 is 1, so this goes only f, 1f minus 0.75 equals, while solving problem, don't make mistake in sign, that is very important. If you make a simple mistake in sign, it's very difficult to locate it or detect it, and then makes your that adds to your confusion. So don't make any sign mistake. Okay, so got it. Yeah, so go step by step, then you will not make any mistake. Okay, the 1 minus 0.5 is zero point 0.5 and 0.45 is like that. You get, okay, zero point 0.3. I'm going step by step. This is equal to f equal to 0.3 upon, okay, that is 3 upon 5 or zero point 0.6. That's the answer. Problem, 7y plus 4 divided by y plus 2 equal to minus 4 upon 3. So this is the problem of the type where we are not given this in a linear form directly. Some unknown term divided by some other unknown term, like that, and equated to a constant, that is now in this example 7y plus 4 upon y plus 2. So these type of examples are to be solved by a process of cross multiplication. Remember, there is very important process in maths or any other subject like chemistry or physics. There is a cross multiplication. You have to always go for a cross multiplication. Okay, so see how it is done. 7y plus 4 divided by y plus 2 equals minus 4 upon 3. Okay, now to the numerator of left hand side you have to multiply by the denominator of right hand side, that is 3, and to the numerator of right hand side minus 4 you are multiplying by the denominator of left hand side y plus 2. So this brings it in a linear form. Now see, now solve it, that is 21 y plus 12 equal to, okay, now bring unknowns or y on one side, that is left hand side, and constant on the other side. You have to always change the sign the moment you change their position on the equal to sign. If it's on right hand side, if you bring it on left hand side, this is for plus minus, and for division, if it is on the numerator side, it will go to denominator, or denominator will go to numerator as shown in the previous step, and if it is plus minus, is always change the sign. Remember this, so there is no confusion. The denominator of a rational number is greater than its numerator by it. If the numerator is increased by 17 and the denominator is decreased by 1, the number obtained is 3 upon 2. Find the rational number. So read this problem very carefully. It says that the denominator is greater by it than numerator. Okay, so you are actually supposed to understand the actual problem. So denominator is greater by 8. Okay. Then if we take numerator as x, then what will be the denominator? Of course x plus 8. So it is very easy to understand if we think properly. So we are dealing with a number, or rather we can say a rational number, x divided by x plus 8. Then what it says further? Now a numerator is increased by 17. That is, we are adding 17 to x. That is in the numerator side. Okay. And then is a decreasing denominator by 1. Okay. Then what we get is x plus 17 divided by, the denominator is x plus 8, and subtract 1 from this. And this number will be 3 upon 2. So we got the equation. Let's solve it. X plus 17 upon x plus 7 is equal to 3 upon 2. Now cross multiply, as we have seen in the previous problems. Now it has become very easy. 2 into x plus 17, the 3 into x plus 7. If we have enough practice, some of these problems can be solved literally orally. Okay, then we are transferring x on one side. This time it is convenient to transfer on the right hand side and constant in the left hand side. So we are doing it. So we get x equal to 13. So number will be 13 upon 13 plus 8. Okay, see, this is given here, x divided by x plus 8. So 13 upon 13 plus 8 is 13 upon 21. Now we check it again. This is the number. How we check? That is, if you increase a numerator by 17 and decrease denominator by 1, as said in the problem, we get 20, 30 upon 20. Okay, so 3 upon 2. That's the